Top 10 legal tractors farmers don't use anymore. They still run. They're still legal. They're still on the books in every state, but ask around and no one's using them anymore. Not because they're broken, not because they're banned, but farming changed faster than they did. From two-wheel drives that once pulled full harvests to compact machines that used to power entire farms, these tractors haven't failed. They've just stopped fitting the system, insurance guidelines, hydraulic demand, precision compatibility. None of these existed when these machines were built, but they all matter now. And even though every tractor on this list can still pass inspection, none of them are on the field anymore. These are the top 10 tractors that didn't lose power. They lost their place. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th, David Brown 990. Still legal, but no longer wanted. 3 decades ago in the northeastern United States, not every tractor came from Illinois or Iowa. Some arrived by container, painted in a muted red-brown, built by a company far from American soil. David Brown, Huddersfield, England. The 990 model entered the U.S. market in the late 1960s through dealer partnerships and limited importation. It wasn't flashy, it didn't roar, but with a 4-cylinder diesel engine pushing 52 horsepower, a narrow-frame chassis, a 6-speed mechanical gearbox, and a single-stage hydraulic system, it delivered precisely what many mid-sized farms needed: fuel efficiency, reliability, simplicity, and independence from high-maintenance attachments. In states like Vermont, Pennsylvania, and across rural New England, the 990 became a quiet staple. On 30 to 80-acre operations, it hauled small trailers, worked in orchards, and pulled single-furrow plows. During the 1973 oil crisis, it was even touted as one of the most efficient sub-60 horsepower diesels available. But the very simplicity that made the 990 attractive turned obsolete. As American agriculture scaled up post-1985, the David Brown 990 showed its limits. It used a non-synchronized 540 PTO that didn't align with ASAE standards. Its hydraulic system wasn't ISO compatible. It lacked a dedicated oil filtration circuit and couldn't deliver sufficient lift for modern disc harrows, hay balers, or post-1980s tillage implements. When Case acquired David Brown in 1972 and began absorbing the brand by the late 80s, technical support for the 990 quietly faded across North American dealerships. Parts became harder to source, often requiring imports from the UK or private collectors. Even at regional ag shows, live working units became rare by the early 2000s. The 990 was never banned. It still passes emissions. It still qualifies for legal use if fitted with a ROPS kit. But farmers stopped using it, not because it failed, but because it no longer fit the farm. Today, a few machines remain in private sheds across Maine or Wisconsin. They can still be started, but no one's asking them to work. Ranked 9th, White 2-105. Still running, nowhere left to go. There was never anything exotic about the 2-105. It was American steel, mid-range power, and parts that could be ordered out of a binder. The kind of tractor that showed up in the morning, worked until sundown, and didn't leave a memory behind because it never needed attention in the first place. Released in 1975, the White 2-105 was born into a brand stitched together from fading giants. White Farm Equipment had absorbed Oliver, Minneapolis Moline, and Cockshut, and what they produced wasn't innovation, it was survival. The 2-105 was a practical answer to a narrowing window. Build something dependable, price it under Deere and IH, and give farmers exactly what they asked for, nothing more. Its Perkins 6-cylinder diesel pushed 105 PTO horsepower without strain. The over-under transmission, White's version of a partial power shift, gave 16 forward speeds with no electronics. Dual-speed PTO, power steering, and a mechanical lift system kept it competitive without overcomplication. No onboard diagnostics, no cab computers, no tier ratings, just torque and gears. For a while it worked. From Ohio to Kansas, The 2-105 found its way into fields that couldn't justify green or red pricing. It was big enough to pull a 5-bottom plow, light enough to avoid tearing the headlands, and simple enough that a single-man operation could keep it going with a basic toolkit and a good memory. But every machine is tied to its dealer network, and the 205's world began to shrink the moment White lost market share to Case IH and Deere in the late 80s. AGCO's acquisition of White slowed parts pipelines to a crawl. The unique planetary gears in the over-under system posed a rebuild risk. Hydraulic couplings no longer matched newer implements. No dealer carried OEM filters, and the few that tried were clearing out what stock they had, not restocking. Farmers didn't retire the 2-105 because it failed. They stopped using it because the support failed first. Even now, with the right tools and time, you can keep one alive. The engine still cranks. The lift still works. It's still street legal in all 50 states. But you won't find it on leased land, contract farms, or modern row crop operations. You'll find it in collector barns, parked between a Super 88 and a 2-135, brought out once a season just to prove it still can, and then quietly parked again. Ranked 8th, Allis-Chalmers WD45, the system that refused to change. It was never the engine that held it back. With nearly 40 horsepower at the drawbar, a factory-installed diesel long before its competitors offered one, and a torque curve that kept going even under load. The Allis-Chalmers WD45 didn't lose ground in the field. It lost it in the factory when it refused to let go of a system designed for itself. Released in 1953, the WD45 wasn't just an upgrade. It was a structural shift. This was the first Allis-Chalmers tractor to bring diesel power into row crop production at scale, giving smaller farms a chance to pull heavier implements without jumping to a higher class of machine. Its weight distribution was clean, its wheelbase stable, and its 4-speed transmission, while basic, kept RPMs in the sweet spot for tillage and belt work. But the defining feature, and the fatal flaw, was the snap coupler system, a proprietary 2-point hitch engineered by Allis-Chalmers. The snap coupler allowed for rapid attachment swaps, but only if those implements were made for it. It locked the WD45 into a closed loop of compatibility, excluding the emerging 3-point hitch systems being adopted across the industry. Farmers could work with it until they couldn't. By the early 1960s, the American implement market had shifted. Manufacturers standardized, dealers diversified, and the snap coupler, once an efficiency advantage, became a limitation. It couldn't accommodate heavier lift loads, it didn't adapt to newer balers, tillers, or spreaders, and it didn't evolve. Nor did the rest of the machine. The PTO remained non-independent. The hydraulics weren't dual stage, and the cab, if you could call it that, offered no roll protection, no shielding, no vertical suspension. It wasn't just old, it was fundamentally incompatible with the machines that came after it. Even so, WD45s ran for decades. Across Indiana and the Ozarks, they raked hay, pulled wagons, and cleared snow from gravel roads, long after more powerful models arrived. Why? Because they didn't quit. They were built in an era where over-design was the default, but strength doesn't guarantee survival in a system that moved on without you. Today, the WD45 exists in 2 places: in collections, where it's praised for how it captured a moment in design, and in barns, where it's still technically operational, but practically unusable. Its manuals are still reprinted. Its parts are still sold, one by one online. But in the active world of working agriculture, no one is waiting for a snap coupler to come back. Ranked 7th, Farmall H, the machine that modern agriculture left behind. There's no debate over what the Farmall H accomplished. It scaled American mechanization during a time when the country had fuel rations, labor shortages, and too many acres to plow by hand. It was built not to impress, but to survive, in numbers, in simplicity, and obligation. From 1939 through 1953, over 390,000 units were produced. In every measurable way, the H was a strategic deployment. 26 PTO horsepower, a narrow row crop stance with adjustable axles, a belt pulley system that made it equally valuable for the barn or the field, and a 4-cylinder gas engine that was underpowered by today's standards. But impossible to kill. It worked because the farms it served were built around it. The implements were light, fields were smaller. The mechanical PTO, though non-independent, could drive basic hay tools and threshers. The steel drawbar didn't need to pull anything bigger than a 2-bottom plow, and no one asked it to haul 12,000-pound grain carts across tilled ground. It did what it was designed to do, for a system that no longer exists. By the time integrated hydraulics, independent PTOs, and 3-point standards became widespread in the mid-1950s, the Farmall H was already complete and already obsolete. Its snap-in lift system was a stopgap. Its 5-speed transmission lacked low-gear torque for modern implements, and without live hydraulics, operators lost control the moment they clutched, a critical flaw for post-war machinery safety. International Harvester never reissued the H, not because it failed, but because the market evolved beyond it. Today, it is still operational. Collectors maintain thousands. Restoration projects are readily available. But in every commercial agricultural setting, lease contracts, insurance guidelines, OSHA-inspected fleets, the Farmall H is incompatible. It has no ROPS, no operator protection, no emission path, no electrical upgrades, no support from modern dealerships. It's not forgotten, it's not condemned, it's simply untethered from the power, the policy, and the platform that modern agriculture now requires. And for a machine that once pulled America forward, that's enough. Ranked 6th, Ford 8N, the design everyone imitated until no one used it. It didn't change farming with power, it changed it with structure. Released in 1947, the Ford 8N was the first tractor to combine mass-market affordability with a working 3-point hitch system, a design that forced the rest of the industry to rewrite their engineering sheets. With 4 forward speeds, a small footprint gasoline engine, and a hydraulic lift system adapted from the Ferguson agreement, it made mechanization possible on farms that previously relied on mules. No prior model had sold like it. Over 500,000 units. At its peak, the 8N outsold every other tractor on the American market combined. Its appeal was obvious. It was small, light, simple to operate, and, for the first time, integrated. Implements attached in seconds. Depth control became standardized. One operator could run plows, seeders, and mowers without unbolting frames or adjusting pulleys. But the innovation stopped at the surface. The 8N never had live hydraulics. The moment the clutch was pressed, the lift arms froze. Its PTO was direct drive, meaning every implement slowed or stalled during gear changes. There was no ROPS, no protection from rollover, no power steering for tight turning loads. By the 1970s, farms had changed, but the 8N hadn't. The implements grew larger. Hydraulics became dual stage. Safety codes evolved. And while the 8N could still start and run, it no longer met the operational needs of even the smallest commercial growers. Its blueprint lived on, in thousands of models that copied or extended the Ferguson system, but the machine itself, it became an artifact. Not broken, not banned, just bracketed by time. Today, the 8N runs better than most engines of its age. It has collectors, restoration parts, even full-service aftermarket suppliers. But in active farming, where precision depth, ROPS certification, and Category 2 lifting are the baseline, there's no task it does that can't be done safer, faster, and better by something else. The design changed agriculture, but agriculture, in return, changed what it required. And the 8N was left where it started, revolutionary, for the farms that no longer exist. Ranked 5th, Oliver 1650, the platform that refused to migrate. It wasn't underbuilt, it wasn't outdated when it launched. It just stayed exactly where it was, while the world of agriculture kept moving forward. The Oliver 1650 entered the market in 1964 as the successor to the 880, the model that helped Oliver stay competitive during a time of fierce 3-way rivalry with Deere and International Harvester. It delivered what farmers asked for: 70 PTO horsepower from a 6-cylinder Waukesha engine, Live hydraulics with respectable flow, a cleanly engineered category 2 3-point hitch, and an optional hydral shift transmission, offering 12 forward speeds without the maintenance complexity of complete power shift units. The platform was balanced. It didn't oversell. It didn't overheat. It ran on small dairies, diversified row crop farms, and even county snow programs in Ohio and Michigan. But it also stopped evolving the moment it met the spec sheet. Unlike Deere's 3020, which migrated into digital platforms, or IH's 706, which was succeeded by increasingly modular designs, the Oliver 1650 remained static, because the brand supporting it was already fracturing. After White Motor Corporation absorbed Oliver in the late 1960s, the engineering roadmap split. Oliver's legacy tractors remained on dealer lots, but without a next generation. There were no modernized cab versions, no higher flow hydraulic variants, no factory support for ISO electrical standards or pressurized air systems. The hydral shift, initially praised in early brochures, eventually became a known failure point due to planetary gear sets that couldn't be field serviced and rebuild kits that dried up by the 1990s. Once it failed, owners had two options: lock it in high range permanently or part the machine out. Its PTO remained usable. Its 3-point hitch could still lift. But by the early 2000s, the 1650 had no viable place in modern row crop operations. It couldn't run modern planters. It wasn't safe under the new insurance codes, and it didn't have the horsepower to weight ratio required for larger tillage systems. Even so, it never became disposable. The machine was built with enough structural overcapacity to survive retirement. Collectors prize it. Mechanics praise its ease of access. And there are regions, particularly in the northern plains, where a few 1650s still haul gravel, spread seed, or drag broken combines to the edge of the field. But function doesn't equal viability. The Oliver 1650 is still here, still startable, still legal, but its lineage never migrated. And in modern agriculture, standing still is the same as being left behind. Ranked fourth, Massey Ferguson 35, the standard no longer specified. Every modern compact tractor can trace something back to it, but none of them are built like it, and none of them are built for it. Launched in 1956, the Massey Ferguson 35 was not a flagship. It was a foundation. At just under 35 PTO horsepower, with a 3-cylinder Perkins diesel and a clean Ferguson 3-point system, the MF35 redefined what counted as enough. It allowed mechanization to reach operations that had been priced out for decades. 20-acre dairy farms, terrace-bound vineyards, and export economies dependent on small-scale yield. It didn't scale, it spread. By the early 1960s, over 500,000 MF35 units had been sold globally, not in clusters, but in layers. One in a banana field in Colombia, one dragging peanut trailers in Georgia, one leveling rice beds in Tamil Nadu. Its system worked because its limits were honest. Category wine lift only, single-line hydraulics, transmission-driven PTO, no ROPS, no power-assisted steering, no emissions framework of any kind. But its simplicity gave it range across borders, languages, and electrical grids. The problem came when agriculture demanded more than access. By the 1980s, tractors in its size class were expected to support dual hydraulic implements, loader arms, hydraulic top links, and rear remotes with load-sensing valves. Even in the developing world, mechanization incentives were tied to horsepower class, safety compliance, and manufacturer warranty traceability. And the MF35, as consistent as it was, couldn't check those boxes. It wasn't replaced, it was absorbed. Its frame inspired hundreds of licensed designs, from Mahindra to IMT to Ursus. Its engine line kept evolving into Tier 1 and Tier 2 platforms. Its hydraulic control system laid the groundwork for the compact utility tractor boom of the 1990s. But the original unit, the one with no ROPS, no data path, no expansion socket, no longer fits. You can still find it on the edge of pastures, dragging limbs, pulling splitters, or leveling gravel on farm driveways. In all those places, the MF35 is still working, But in the equipment fleet of a commercial leaseholder, an ag lender, or a USDA-aligned co-op, it has been excluded by specification. The MF-35 didn't fail. The world simply stopped writing it into the equation. Ranked third, International Harvester 1066. The power limit that couldn't be passed. It was never the bottom of the line, and that's what made its limits visible. Released in 1971, the IH-1066 wasn't just powerful, it was purpose-built to push the boundaries of what a two-wheel drive row crop tractor could handle. With a turbocharged DT414 diesel engine generating over 125 horsepower at the PTO, it pulled faster, deeper, and longer than most of its competition, right up to the point where its frame started showing strain. The 1066 was a volume machine. It filled barns from Iowa to Nebraska, pulling 6-bottom plows, 21-foot discs, and gravity wagons loaded past spec. Operators trusted its torque. Dealers moved it fast. An International Harvester relied on it as the spine of the 66 series lineup. But for every strength, there was a ceiling. The 1066 used a torque amplifier system to multiply pulling power in the field. But that system, brilliant on paper, became a known failure point in real time. Under load, especially during downshifts on slope, the TA units failed, requiring complete split repairs that cost as much as smaller tractors. I tried to improve durability, but the architecture remained fixed in a drivetrain that was never designed to be modular. Its cab, though protective by early standards, lacked soundproofing, temperature control, and ergonomic layout. Electrical systems were analog and non-isolated. Hydraulics were single-line with limited rear flow, and by the 1990s, the 1066 couldn't run any implement requiring intelligent control, GPS correction, or dual-return ISO hydraulics. The machine itself was never the problem. It was the system around it. Dealership support, part pipelines, and ag tech expectations that moved on. Today, 1066 still fire up. Collectors rebuild them. Pulling leagues race them. They're remembered, not because they broke, but because they broke first when farms got bigger, faster, and more connected. What 1066 proved was clear. You could get considerable power out of a mid-frame tractor. What it couldn't do was survive the generation that followed. Ranked second, Case 930. Comfort King, the design that couldn't be brought forward. In its time, it made sense. Wide stance, high visibility, torque where it counted, but no part of it was made to adapt, and that's why it stopped. Released in 1960, the Case 930 Comfort King was not a technological leap. It was a geometry shift. By repositioning the operator's station above the rear axle and lifting the seat, steering column, and control deck up and back, Case changed the driving posture of American field tractors. No more nose-heavy lean, no offset view. The Comfort King gave full row visibility, higher ground clearance, and weight redistribution, all without adding electronics, sensors, or cab controls. Under the sheet metal, a naturally aspirated 6-cylinder diesel engine built for field torque, not road speed, a 6-speed transmission, later upgraded to 8-speed, a 540 PTO that could pull most drawbar implements of the era, open hydraulics, manual levers, and a live PTO system that helped define the row crop class of the 1960s. But geometry doesn't scale with expectations. By the late 1970s, Comfort King's frame layout and mechanical systems had no path forward. Its powertrain wasn't modular, its PTO was locked to engine speed without slip management, and its hydraulic flow, under 10 GPM, was too low for loader arms, downforce drills, or even some post-1985 plows. Worse, its operator station, once called Comfort, lacked ROPS, sound shielding, suspension, or ergonomic control groupings. The machine wasn't dangerous, it was simply rigid. As tractor platforms moved toward modular chassis, electronic compatibility, and closed-center hydraulics, the Case 930 couldn't follow. There were no retrofit kits for digital monitoring, No tier-rated versions of the engine. No integrated cab that passed modern safety standards. It still starts, still pulls, still idles like a freight engine at 1,200 RPM. And for snow plowing, bush hogging, or towing stuck trailers, it can still outperform tractors half its age. But in the structure of modern agriculture, leasing, insuring, mapping, multi-pass automation, the Case 930 has no port of entry, no isobus, no draft feedback, no platform support. It was a correct design for a closed set of conditions. And when those conditions disappeared, so did the 930's future. In first place, John Deere 4020, the machine that had nothing left to prove. Nothing is missing from its record. No major flaw, no catastrophic recall. The John Deere 4020 wasn't replaced because it failed. It was replaced because it did too much, too well, for a world that kept growing anyway. Released in 1963, the 4020 defined the mid-century pivot point between mechanical reliability and scaled production. It brought 95 to 105 horsepower to the drawbar, a powerful six-cylinder diesel engine, synchro range or power shift transmissions, dual hydraulics, and an independent 540 over 1,000 PTO, all packed into a chassis strong enough for six-row equipment, yet compact enough for two-man farms to operate solo. It was the first tractor that didn't have to be explained. You either had one or you farmed next to someone who did. John Deere sold over 175,000 units in under a decade. It dominated the Corn Belt, filled barns across the Great Plains, and helped standardize implement design across manufacturers. Dealers built their entire service infrastructure around it. Parts pipelines stabilized because of it. The entire equipment generations were benchmarked against it. But that kind of dominance comes with an endpoint. By the late 1980s, the 4020 specs were still solid, but the system around it had changed. Precision depth control, closed center hydraulics, cab climate systems, and multi-speed rear remotes became standard. Emission standards changed, financing criteria changed, and the labor model shifted from four-season operators to multi-pass digital workflows. The 4020 had no path into that system. It had no GPS ports, no ISO hydraulic logic, no tier-rated powertrain. And though it could still plow, plant, and pull, it couldn't document, adapt, or report. The machine was never the bottleneck. It was the platform. In a system that now requires integration, not just strength, platforms that don't connect get left idle. Today, the 4020 is still running. Its engine hours are still tracked. Its parts are still manufactured. It still pulls hay rakes and blade scrapers across thousands of acres, but only in tasks that the rest of the fleet no longer needs to do. There's nothing else it needs to prove, but nothing is left to be asked to do. And that's how the 4020 exited. Not through failure, not through retirement, but through success that couldn't scale. They weren't forgotten. They were finished by systems that demanded more than they were built to give. Each of these machines earned its place in farming history, and each was quietly sidelined, not because of wear, but because of change. Technology didn't break them, it moved the baseline. Today they remain legal, restorable, and sometimes even running. But their role in agriculture, as primary tools, is over. Understanding why matters. Because in farming, obsolescence doesn't come from failure. It comes from everything else moving forward. They weren't forgotten. They were finished by systems that demanded more than they were built to give. Each of these machines earned its place in farming history, and each was quietly sidelined, not because of wear, but because of change. Technology didn't break them. It moved the baseline. Today they remain legal, restorable, and sometimes even running, but their role in agriculture, as primary tools, is over. Understanding why matters. Because in farming, obsolescence doesn't come from failure. It comes from everything else moving forward. Let us know which one resonates with you in the comments, and don't forget to like and subscribe to our channel for more content like this.